Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, I am Rizwan Aslam Razi and I am here to teach you mathematics. Remember students, only those students succeed in their life who obey their teachers. So keep in touch and obey your worthy teachers in these online classes. Let's start our lecture. We are going to start chapter number 5, which is about partial fractions. But before I start about our topic today, you must know what is fraction. The quotient of two polynomials px over qx, where qx is not equal to 0, is called rational fraction. For example, x plus 1 over 2x square minus 1 is a rational fraction. But students, what is fraction? The quotient of any two numbers are the quotient of any two algebraic expressions is known as fraction. But when the quotients are polynomials, the fraction is known as rational fraction. Remember students, in our previous classes, in junior classes, we have learnt about the fraction. 5 over 6 or 7 over 5 or something 1, 3 over 6. These type of numbers, we learnt about these numbers that these are fractions. But in this chapter, whenever I talk about fraction, it means rational fraction. A fraction whose numerator and denominator both are polynomials. And you know very well about polynomials, as we have learnt about these in matriculation. For your convenience, I would like to explain a little about these polynomials, that when an algebraic expression have the positive powers or the powers of whole numbers is known as polynomial. Let's move to our next slide. There are two types of fraction. I repeat my words that here in this chapter, whenever I talk about fraction, it means rational fraction. So there are two types. Proper fraction means proper rational fraction. If the degree of px is less than the degree of qx, when the degree of px is less than the degree of qx, the fraction is called proper fraction or proper rational fraction. For example, 2x minus 5 over x square plus 4. The degree of numerator is 1, as the highest power of x is 1. On the other hand, the degree of denominator is 2, as the highest power of variable in denominator is 2. So the second type of fraction is improper fraction. If the degree of px is greater than or equal to the degree of qx, then the fraction is known as improper fraction or improper rational fraction. Here we see that the highest power in numerator is 3. So the degree of numerator or the degree of px is 3, and the degree of denominator which we have denoted with qx, is 2, as the degree of numerator is greater than the degree of denominator. So this given fraction is the example of an improper fraction. Moving on, students, you must know about coefficient theorem, that if two polynomials are equal, the coefficients of like powers of the variable in both polynomials must be equal. It means that if we compare two polynomials, then on both sides the variables having same powers must have the same coefficient. For example, here 2x square on left hand side has the coefficient 2, but on the other hand, at the right hand side, the coefficient of x square is a. This means that the value of a is 2. Similarly, the coefficient of x on right hand side is b, and the coefficient of x at the left hand side is 3. It means the value of b is 3. And the coefficient of a variable having power 0 means a constant number. On right hand side is c, and on the left hand side it is -5. It means that the value of c is -5. Remember, students, whenever we compare two polynomials and we don't have any one of the power at one side or on the other, the coefficient of that variable will be considered as 0. For example, in our next example, we have 3x minus 5, and we don't have x square in left hand side of this equation. But on the right hand side, there is the coefficient of x square. It means that the value of a must be equal to 0. According to the coefficient theorem, we can conclude the values of variables. One thing more, students, if there are two or more than two coefficients with having same powers, we sum up them, we take common the same variable having the same power, and then compare the coefficients. It may result in the form of linear equations, and after solving those linear equations, we will obtain the value of unknowns. Let's move on. Now I am at my topic, that is partial fraction. The process in which a single rational fraction is expressed as a sum of two or more single rational fractions is called partial fraction. For example, we have 2x minus 5 over x squared minus 1. The denominator of this rational fraction is a formula which is a square minus b square. If we simplify this formula into its linear factors, it will be x plus 1 and x minus 1. So we make the partial fractions of these two linear factors x plus 1 and x minus 1. So the first partial fraction will be a over x plus 1 and the second partial fraction will be b over x minus 1. Remember students, if there are three linear factors in denominator, then there will be three partial fractions, and we always use the sign plus between these partial fractions. Students, in our junior classes we have learned something as I have expressed at the bottom, that 3 over 5 is equal to 1 over 5 plus 2 over 5. In class 5 we have learned to solve these questions, that we sum up 1 over 5 plus 1 over 2 to make 3 over 5. Here I can explain our topic that 3 over 5 is a fraction and 1 over 5 and 2 over 5 are the partial fractions of 3 over 5. But these are the fractions of numbers, so we don't name them the rational fractions. These are only fractions. Moving on, we have another example, which is the question number 9 of your exercise 5.1. The denominators are x minus 2, x minus 4, x minus 6. So there will be three partial fractions, a over x minus 2, b over x minus 4 and c over x minus 6. Students, I suggest that you must do practice at home to make partial fractions of exercise 5.1. And remember students, math is a such type of subject that you must practice daily. If you want to learn more, you must have to do practice of mathematics, as we know that practice makes a man perfect. So I do suggest that you must practice at your homes for this first rule of partial fractions. Thank you so much.